Okay, so I'm going to do a special video on derivatives today. So it's going to be a long video and it's going to have a lot of different concepts about derivatives in it. So it's going to be about 30 minutes long. So we have a lot to cover, so you should probably pause in the middle and not watch the whole thing at the same time. You should probably not watch it all in one sitting. So we're going to go over stuff about derivatives in this video. So let's get started. So we're going to start by I'm going to list the derivatives of a few important functions. So first we're going to start off with the derivative of x to the n. So to write the derivative of a function, we write that function prime. So this little tick mark here, that means the derivative of the function. So x to the n prime equals n times x to the n minus 1. So if we have x to some power, the derivative of that function is n times x to the n minus 1. Now let's do mx to the n prime. So it's a multiple of x to the n. That equals mn x to the n minus 1. So m times n times x to the n minus 1 power. So those are the two power rules for derivatives. Okay, so I'm going to erase this now. So that's the power rules. And then we also have that the derivative of 1 over x prime equals negative 1 over x squared. This isn't a 1, this is a prime. So that's another rule. Then we have the derivative of sine of x equals cosine of x. So this rule is pretty important. Then we have the derivative of cosine of x equals negative sine of x. And then we have the derivative of tan of x equals secant squared of x. So these are trigonometric derivatives. So these are also pretty important. And so these are the rules we're going to use. And now we're going to go over the product rule. So the product rule says that f of x times g of x, the derivative of that, equals f prime of x, g of x, plus g prime of x, f of x. So if we have two functions multiplied by each other, the derivative of that equals the derivative of the first function times the second function, plus the derivative of the second function times the first function. So it's kind of symmetric. So that's the product rule. And I'm going to do one example of this. So let's say we have cosine of x times x squared, and we want to find the derivative of this. Well, the product rule says it's the derivative of the first function. So the first function is cosine of x. So the derivative of that is negative sine of x, which we went over in the rules before. Then we multiply that by the second function. Then we add the derivative of the second function, which is 2x. So the derivative of x squared is 2x. And we multiply that by the first function, so cosine of x. So the derivative of cosine of x times x squared equals negative sine of x times x squared plus 2x cosine of x. So that's the product rule. So remember, we took the derivative of the first function times the second function plus the derivative of the second function times the first function. So I'm going to rewrite the product rule so you remember. So it's going to be, let's say we have two functions f and g, then fg prime equals f prime g plus fg prime. So the derivative of the first function times the second function plus the first function times the derivative of the second function. So fg prime equals f prime g plus fg prime. That's the product rule. And now we're going to go over the quotient rule. So the quotient rule is to find the derivatives of the quotient of two functions. So f over g prime, so f of x divided by g of x, the derivative of that equals f prime g minus fg prime over g squared. So this is a really weird rule, but that's the quotient rule. So let's do an example. So let's say we want to find the derivative of, let's see, x cubed over sine of x. So this looks pretty complicated, but if we use the quotient rule, we know that this equals the derivative of f times g, so the derivative of x cubed is 3x squared, and we multiply it by g, which is sine of x, so 3x squared sine of x minus f of x, which is x cubed, times g prime. So the derivative of sine of x is cosine of x. And this is all over g squared. So in this case, g of x is sine of x. So g squared would be sine of x squared. So that's the answer. So the derivative of x cubed over sine of x equals this thing right here. Remember, the quotient rule says that the derivative of a quotient of two functions equals the derivative of the first function times the second function minus the first function times the derivative of the second function over the second function squared. So this is the quotient rule. And now we're going to do the chain rule. So what the chain rule says, if you have a function f of x, and let's say that instead of plugging in an x here, you plug in another function, so you have f of g of x. So examples of this are sine of x squared. See how this is a function of a function? So g of x is x squared, and f of x is sine of x. But instead of plugging in x, we're plugging in the function x squared. So the chain rule helps find derivatives of functions like this. Another example would be x plus 2 squared. So the f of x is x squared, g of x is x plus 2, so it would be x plus 2 squared. So the chain rule helps us find derivatives of functions like these. So what it says is that f of g prime, so f of g of x prime equals f prime of g of x times g prime of x. So what does this mean? So let's do the example of sine of x squared. So in sine of x squared, g is x squared, f is sine of x. So f prime of g of x would be the derivative of sine of x, which is cosine, of g of x, which is x squared. So it would be cosine of x squared, and then you multiply it by g prime of x. So g of x is x squared, so g prime of x is 2x. So the derivative of sine of x squared equals 2x times the cosine of x squared. How I remember it is it's the derivative of the function, but instead of x, you're plugging in whatever's inside here, so x squared, and then you're multiplying it by the derivative of the function that's inside. So the function that's inside in this case is x squared, so you're multiplying it by the derivative of that, which is 2x. So this is the chain rule. Let me rewrite it again. So f of g of x, the derivative of that, so f of g of x prime, it's actually going to be like that. So f of g of x prime equals f prime of g of x times g prime of x. Let's do another example of the chain rule because it's kind of complicated. So let's do cosine of x cubed. So the derivative of cosine is negative sine. So the derivative of this would equal negative sine of x cubed times 3x squared. Since 3x squared is the derivative of x cubed, and so we're multiplying it by the negative sine of x cubed because the derivative of cosine is negative sine. So this is the chain rule. So that's another important rule for derivatives. So now what I'm going to do is I'm going to write the rules. So the product, the quotient rule, and the chain rule. So I'm going to make like a table. So the product rule says that fg prime equals f prime g plus fg prime. The quotient rule says that f over g prime equals f prime g minus fg prime over g squared. These f and g's are all functions. They're not variables. They're functions of variables. So the chain rule, it needs more space, so I'm going to put it right here. The chain rule says that f of g, remember g isn't a number, it's a function. So f of g prime equals f prime of g times g prime. So that's the chain rule. So these are the three most important rules of derivatives. So you should probably remember them. So thankfully this video didn't take as long as I thought. So it's only 13 minutes instead of 30. But I hope you learned the rules for derivatives in this video. And just remember that these variables aren't numbers, they're actually functions. So f is actually f of x, so it could equal x squared, x cubed, x to the fourth, or sine of x, or anything. And g of x could also equal anything, so x squared, x cubed, anything for x. So remember that these letters aren't variables, they're functions. And just remember these rules, and I hope you like this video.